So, video 3, part 3. Still not sure how this is going to be uploaded to you all, but I'm assuming you're listening. So, once you do all of your prep work, you understand where your data has come from, you've identified your research questions, your hypotheses, you've looked to see how all your variables are collected, which variables are most important for you to use, the most up-to-date, in a big longitudinal data set like the one I just showed you in the last part of the video. You want to make sure when you have all your ducks lined up, you understand it, you understand the data, you understand the how this data can be generalized to your population, then you can actually begin to prep your data. I'm not talking about planning like we did, doing all your homework and putting everything on a notepad. I'm talking about actually getting your physical data in your data set in SPSS or SAS or whatever you eventually use ready for your analysis. This isn't a hard and fast rule, but you should document everything. Do a data planner or a data diary. Take a scrap of paper and say, day 1, I worked on it for 3 hours, and this is my goal, this is what I did. I converted this to this, transformed that to that, yada yada, you get it. And you can create kind of like your own mini code book, describing the original and recoded variables of interest that you're working with. So, highly recommend transferring all potential data of interest to a new file in your program so that you have a separate working data set. Never alter the original data file. Always have a separate one. So for example, I think if I go to, there we go, there's all my chapters. So here I have, for example, this was my master data set. And then each time I coded it mess. So this is my mess with. These are, and all my different things I did while prepping this is just my dissertation. With 20 people, I had multiple different ways to set up the data here, another week later, longitudinal setup, person period, different types of instrument clumps. You can do this all with your data too. First, never overwrite the original data set. Always have a separate one. Once you're in there and you've identified your variables, you start to look for missing data. You can label missing values in the software program if that's your thing, but as you know, we have taught you not to. See, like this, missing, none. Keep it that way. We're not going to put like 99 like some people do. Nope, nope, nope. When possible, use knowledge of skip patterns to recode missing data as meaningful values. So, for example, if we go back up here, this would be a skip pattern, right? We actually know that they're no's. So imagine this didn't exist, and we needed to make a number-based one. We would do some investigative work on the forums and know that this used to be yes, no, but they only recorded yeses. All no's were recorded zeros. So we can actually put a value of 0 in for our no's now and 1's for yeses. So that's what that means. You need to have a method for handling missing data if you're going to try to use the most robust data set possible. Multiple imputation, maximum likelihood. There's a few different ways, and we're going to talk to you more about those, I do believe, next month. You're going to have to recode variables. You are living a pipe dream if you don't think you're going to have to recode variables. If something's negatively worded, you're going to want to reverse code it so it makes more sense. You're going to dummy code dichotomous values into 0 and 1 instead of using 1 and 2, or blanks in 1s or blanks in 2s. 0 and 1s make a lot of sense. That should make sense to you all right now, and if it doesn't, we're going to have to remediate that. Why you want to use 0s and 1s. You're going to recode all other categorical variables. This may not exactly make sense to you right now, but when we go through our practice example here in a few slides, it's going to make a whole lot of sense why you're going to want to recode an already categorical variable. We're going to combine separate but like variables when necessary. If you see height and weight and there's not a BMI, write the code to calculate BMI. Very important here to recode variables so that all responses are based on the same units. There's a very good reason I put this in here, because if this data set, your variables of interest are all yes and no's and they're strings, they're words, we need to run statistics on numbers, not words, right? There's a phenomenal possibility you're going to have to create new variables. You might need to create or recreate composite variables if you or your research question disagrees with the original conceptualization. Older datasets may interchange race and ethnicity as one combined variable, and socioeconomic status might be one or multiple indicators. So you might need to parse that out or combine stuff, just depending. Those are two common examples that have changed historically over time. What comprises them and how they've been defined and how they've been coded differently over time. Very important here. You should understand psychometric statistics now, since this is technically your Saturday lecture. The psychometrics may not hold to the original construction. There are multiple versions of the self-care heart failure index. Switching it up, I will. If we've been using a heart failure data set on and off throughout the past semester in this one with heart failure data. If we used a self-care index that was collected from 2009, with the most up-to-date version being updated in like 2018, we really can't translate self-care measures of then to today. It's a limitation of secondary data. So, once you've identified everything, you've done your homework, you've figured out all your variables, how you're going to do it, you've looked at the data itself, you've cleaned it up, you've organized it all, then you have to go, hopefully you have already in mind your statistical analysis technique, but then you have to go about doing it. In your software package, this isn't really applicable to us, unless you know. We've done this. This is just repeat. This makes sense. We've talked about inclusion of covariates before, so we have, I'm going to talk a little bit about more of this. So once you've identified everything, and you can go ahead and you can run your preliminary analysis. Here are some other things once you run your analysis to consider, okay? Are there covariates you have not considered? So let's say you're here and you've done everything. You've done all your homework. You've done all of these things. You've analyzed your data. Conduct primary analysis and interpret the results, right? You're right here. You've done that. And you get your results. Let's say you did some sort of complex hierarchical linear regression. And you didn't really find what you want. Were there other covariates in play here? You get into it and you are trying to replicate a well-theorized finding, and let's say you're in P's, and you know historically age has been a predictor of something. Well, you might go back and look at why age isn't a predictor for you right now, and you might find out that age at the time of the child assessment was not possible to be collected, and there's a publication on it that says, oh yeah, these are estimates and may not be accurate, because if you're collecting data on 3-year-olds, the difference between a 3 and a 4-year-old is huge. The difference between a 2.5 and a 3-year-old is massive in terms of developmental milestones in those ages. So it's an example from Dr. Shalaha's work of children in terms of covariates and how age might change. There could be subpopulations. There could be latent constructs, and you should have at least small understanding of latent constructs from our validity lecture now. You could have specific domains or subpopulations built into your data that it's important to make groups out of. If you deleted cases, um, that could confound your results. If you were going through screening and finding outliers and you accidentally deleted instead of excluded outliers, that can really screw up your results. And also, in general, this is a good bullet point because it's a dual purpose. It can throw off your analysis, one, but also don't delete the data. Don't mess with the original data source. It shouldn't be identified at all, but if it is, you need to protect confidentiality, in which then you can consider deleting cases. But if you have a national data set that has patient identifiers, you need to contact the people you got it from. This really isn't extremely important to us, but some restricted use data sets have unweighted sample sizes to be rounded or estimates based on small samples to be suppressed. So that just means, if you have some sort of special data set, it could have some funky algorithmic rules or some sort of requirements from the data agency. You'll know if you have one of those. What we're going to be going through for the purposes of this class really will have nothing to do with that. And you have to be careful about multiple imputation and plausible values if you're plugging in missing data. Alright, so I'm going to stop here and I'm going to make a whole video on working through a hypothetical question through everything we just covered for secondary data analysis to show you, one, how easy it is to come up with a question, but two, how difficult it can be to actually complete that question.